Welcome. We're going to answer this question before us. It says the function this right here has this domain. Where will it have an inverse function if a is which of these values? So what does the domain have to be in order for this to have an inverse function? The first thing you need to know is that an inverse function only exists if f of x is 1 to 1. That's the only time it exists, if f of x is 1 to 1. Okay. So what we're going to have to think about is, what does being 1 to 1 mean? It means it passes the horizontal line test. So that kind of gives us visual. So if you wanted to, what you could do is just sketch this graph and see what it looks like. So let's come over here. Whoopsie daisy. Let's go Control at doc. We want to add a graph page. We want to go x squared minus 8x plus 1. Hit enter. Menu. Window zoom, let's zoom out a bit. Okay, that's good. All right, so there's our graph right there. Now, as you can see, this is what the graph looks like, and we need to figure out where it would be 1 to 1. Hopefully you can see at the moment, if I was to draw a horizontal line through this, well, I'm definitely going to touch it twice, aren't I? So I'm going to have to really consider what this minimum value is here. So let's just do that. Let's go menu, analyze minimum from here to here. As you can see, the minimum value is 4. Okay. Now, if a is less than 4, would this thing be 1 to 1? And it's not going to be 1 to 1. Now, hopefully you can see just by doing that, but let me go through this slowly. But in a real situation, we don't work through these quite quickly. Okay, if a is less than 4, let's think of a number less than 4. 1, for example. So for this one right here, I want you to picture what would 1 to infinity look like. Well, 1 would be what? Somewhere here? So that means the graph would look like this. Do you see how if I was to draw a line through that, it's still going to touch it twice? So that's no good. What if it was less than or equal to something less than 4? Well, 1 would still work here, so that doesn't work again because it would still look something like that. What about a is less than or equal to negative 4? Well, where's negative 4? Well, negative 4... And sorry, it's saying like a is less than, or is greater than negative 4. But all right, what's greater than negative 4? Let's say negative 3 is greater than that. All right, so now let's think about what that would look like for a second. Well, do you agree that negative 4 is like even further up here? Because negative 4 would be like there. So it's going to be like here. So it's going to look something like this. Whoa. Do you see? This is even worse because look, you can draw more horizontal lines through it. So that's no good. This one's no good. Actually, is it? A is greater than or equal to 4. This E is no good because it's just kind of the same as C. D has to be your answer. And let's think about it for a second. If A is greater than or equal to 4, well, that works because here's 4. If it's greater than or equal to 4, that means it's going to look like this. It's going to look like 4 to infinity, right? There's 4. It's going up like that. Do you see how it's only one part of the graph? This works because when I draw a horizontal line, it's only ever going to touch it once. D's your answer. There are other ways of doing this question. If you wanted to, instead of sketching it, you could have just said, well, let me complete the square. So you could have gone menu, you could have gone algebra, you could have gone complete the square of this graph, minus 8x plus 1, complete the square 4x. It's going to be that right there. And then from this, you can kind of figure out that it's going to look like this, 4, negative 15, and then you just think through logically each of these examples as we did here to get your answer. So you didn't necessarily have to sketch it. You could have completed the square, and then once you've completed the square, think through logically all of your ones to see which one would pass the horizontal line test. Hopefully this has made sense. I'll see you in the next one.